Question 5, we have a particle projected with speed 7√5 at an angle inverse tan 2 to the horizontal up the line of greatest slope of an inclined plane of angle inverse tan 1/2. Show that the time taken for the particle to reach the greatest perpendicular height above the horizontal and above the plane are in the ratio 4:3. Okay, let's start with a horizontal plane, and we're just projecting like this. I'm going to call this the angle A. So this is just back to our projectiles on a horizontal plane. 7√5 cos A in the I direction plus 7√5 sine A in the J direction for my vector. So we have an inverse tan of 2 to the horizontal. Don't mess up these easy parts. The inverse tan of 2 is 2/1, which would give this √5. So the cos of A is equal to 1/√5. The sine of A is equal to 2/√5. So my initial vector is going to be 7√5 by 1/√5. That's just going to give 7i. And 7√5 by 2/√5 is going to give 14 in the J direction. So now, to get the greatest height, it's going to be half the time taken to get to there if there was no inclined plane. So we can look at when velocity is equal to 0 in the y direction, v of y is equal to 0 here. We can do it two ways. If we say v of y is equal to 0, therefore u plus at is equal to 0. So 14, a is equal to minus g times t is equal to 0. So t is equal to 14/g to get halfway up. You could check that it takes 28/g to get all the way. S of y is equal to 0 at this point here. Ut plus a half at squared is equal to 0. So 14t minus gt squared over 2 equals 0. Factor out your t to get 14 minus gt over 2 equal to 0. So your initial time is equal to 0, and then we have 28 is equal to gt. So 28/g is equal to t, which you can see is twice the greatest height. So that's if it was just the horizontal. Now what's going on is it's being projected up. Well, the inclined plane is still there, but we're just imagining that it wasn't there initially, so it's being projected up this way. And at this whole angle here, beta, so it's imagined that this is the angle, it's to the horizontal. It's going to be b minus a. So my vector here dealing with the incline, it's going to be the b minus a, so it's going to be u cos b minus a in the I direction plus u sine b minus a in the J direction. We still have the 7√5. Now the cos of a minus b, or b minus a, is equal to cos a cos b plus sine a sine b. So we have the cos and sine of a, so the angle b, this one we can get, that's going to be the whole angle. So the inverse, the tan of 1/2, if we call that the angle b, 1/2 is going to be just the other way around. It's going to be √5. So the cos of a will be 2/5. Sine of a will be 1/5. So cos a cos b, you can see if I'm sorry, they should be b's. Cos a cos b is going to be 1/5 by 2/5, as is sine a sine b. They're going to be the same, so we're just going to get 2/5 for both of these. So that's 2/5. Cos a minus b. Cos a cos b is 2/5. And sine a sine b is 2/5. That's equal to 4 over 5. Now we need to look at the sine of b minus a. Well, if the cos of an angle, let's say call this angle, let's just call it x. If the cos of x is equal to 4 over 5, or the cos, just instead of putting two letters in it, adjacent over hypotenuse, this would leave 3 here. So the sine of this angle x, which is your a minus b, is going to be 3 over 5. So that will get us into this question here. So we have we have the cos of b minus a, and we have the sine of b minus a. 4 over 5 and 3 over 5. So 7 root 5 times the cos of the angle, 4 over 5 in the I direction, plus 7 root 5 times 3 over 5 in the j direction. And that's going to give 28 root 5 over 5 in the I direction, plus 21 root 5 over 5 in the j direction. Now the greatest height, we need the velocity of y to be equal to 0. So the acceleration of y, just go back up to our diagram, the accelerations is based on the angle A. So A, the acceleration in the I direction, is going to be minus g sine A. And in the j direction, minus g cos A, which is the one we need. So minus g by 1 cos A was 1 over root 5. So minus g over root 5 for your acceleration in the j direction. Minus g over root 5. This is for the j. So the velocity in the j direction will be equal to 0. So v is equal to u plus at. So 21 root 5 over 5 minus g over root 5 times the time. So we need the time. And hopefully it will be in the ratio that we're looking for. So when is the velocity of y equal to 0? So 21 root 5 over 5 is equal to gt over root 5. Cross multiplying, we're going to get 21 times 5 divided by 5. So that's going to be 21. Just double check that. Yeah, 21 times 5 divided by 5. And then that will be divided by g is equal to t. So we have 21 over g. And the other one we had, if we can find it, was 28 over g. 21 over g to 28 over g are the ratios. Just cancel the g's and we get 3 to 4. Hopefully that's what they're looking for. I think it's the other way around, 4 to 3, but it's the same answer, 4 to 3. We just have them the wrong way around.